Welcome, Mantella here with another Math Methods tutorial. Today I'll be doing question 9 at parts A, B, C, D, and E from exercise 1.4. So 9a asks, sketch the graph of y equals x plus 1 and x take 2. So I fixed this, I've got my mouse now, you can see it hopefully. When I click, apparently something happens, I changed something. So sketch the graph, this question you're allowed to use technology for, and teachers encourage using technology, so that's what I did, I graphed it. And this is what you get. You can put it in straight as x plus 1, x take 2 in the brackets like that, and it will come up with this. Or you can expand it and put it in either way. It's quicker to do this, but whichever way you prefer will work. State its domain and range. So domain the x values. Now this graph has no restrictions on it, no like logs or anything, so it's basically just going to go all the way that way forever and all the way that way forever. And yep. So range is, you can see here that it only goes down so far and it's going to go up for the rest of forever. Easiest way to find this out is to do a graph trace, or you can solve for when, I don't know, solve for when it's at a minimum or whatever, but graph trace is the easiest. So minimum there, I can click on that and it'll stay there. You can see that's 0.5 on the x and negative 2.25 on the y. So the range is just going to be all y values equal to or greater than negative 2.25. The function has now translated 2 units to the right. State its equation. So if we see this graph here, basically to move it 2 units to the right, this point here would have to be moved to there, and this point here would have to be moved to there. So if we change this plus 1 to a take 1, because that will move it 2 units this way, and this take 2 to a take 4, it will also move it 2 units that way. That will give us our new equation, and that is what the graph looks like, x take 1, x take 4, and it has moved it across 2 units as this question asks. State the range of this function. The range stays exactly the same because it's the y values, and you can see they both have the same minimum point. They also have the same domain as well, so it's the same domain and range for both of these equations, but it's not asking for the domain. Question E. The function is now dilated by a factor of 2 units parallel to the y-axis and is translated 3 units in the negative direction parallel to the y-axis. State its equation in expanded form. So dilating by a factor of 2 parallel to the y-axis means this equation is going to get steeper. It's going to get more in this way. And translated 3 units in the negative direction parallel to the y-axis. So parallel to the y-axis is going along this way, and then the negative direction is going down. So it's going to go down by 3 units. And it just wants you to state its equation in expanded form. So this is the easiest way I found to do it, following these procedures. So first you'd add the dilation factor of 2. So because you're dilating parallel to the x-axis and not like away from the parallel to the y-axis, I should say. There's another way you can say it. I think it's like from the x-axis or something. But if it's, yeah, but that would be a power of a half or whatever. But you just put the 2 out here, and you get expand it like that. So you write 2, and then your brackets in there, and it'll put the times in where they need to be, and you get 2x squared take 10x plus 8. And now the next step is to move the graph down 3 units. So moving it down 3 units is sort of going negatively parallel to the y-axis like the question asks. So basically I've just got the equation in here and subtract 3 at the end, and gives you the final equation here, 2x squared take 10x plus 5. And that's the final equation. So I'll show you what the graph looks like just for good measure. That is the graph there. You can see it's steeper, so it's a bit thinner than the other graph, and the turning point has been moved down significantly. So yeah, thanks for watching guys, hope it helped. See you in another video.